Hey, grade nines, Mr. McIntyre here. I hope everybody's doing really well and had a really nice weekend. We're starting a new unit on surface area, and let's get into it. So this is an intro to surface area. So do you remember doing the Pythagorean theorem? So it only works on right angle triangles, and it can tell us the third side of a triangle when we know two sides already. So I'll show you um, on here. Hopefully I can draw this all right. If I have a right angle triangle, this is right angle here. So this side we'll call A, and this side we'll call B, and this is C here. So what the Pythagorean theorem tells us is that the side length of A squared plus the side length of B squared gives us the hypotenuse, which we'll call C, squared. So if we have A here and we square it, if we multiply A times A, that'll give us a square of A squared. And then if we multiply B times B, that'll give us a square with an area of B squared. And if we multiply C times C, I don't know if I'll have enough space here, we'll get a square of C squared. So the area of this small A squared plus this square B squared will equal the side C squared. I have a little video here to show you guys. So this is proving Pythagoras' theorem. So here are four little triangles. I hope you can see this okay, all made into a big square. So if we have a triangle, we'll look at this one in the top corner here. If we have A right here is the small side, and then another side B, and then it finds us the hypotenuse C. That's the hypotenuse. So the hypotenuse squared, which is C squared, is equal to this pink area. So this pink area is C squared. So we're going to see, it's going to show in this video, it's going to move some stuff around, but it's going to show how A squared plus B squared equals C squared. So we have A squared here, and we have B squared up here, and it's the same area that we had with C squared. I don't know if this helps you guys understand, but it's just another way of understanding. I can post this link too if you want to read through it. It's pretty interesting. Okay, what else do we have to touch on? Surface area of simple 2D shapes. So circles, triangles, and rectangles. Let's go back to our spot here. Make a new grid. All right, so if we have a circle, sorry, it's not a very good circle, and we want to know the area, we'll call this R, that's the radius R. So the area of a circle is, so A equals, the area equals pi times the radius squared. All right, so if we have the radius here, let's just do a practice problem. So if the radius, let's say, is 2 meters, called R equals 2 meters, then we'll have the area of the circle equals pi times 2 meters squared. All right, so the important part for this problem is not the number that comes out afterwards. I'm not sure what it is, but you guys can look it up. But the units. So I included 2 meters in here, but when we take 2 meters and multiply it by another 2 meters, which is what we're doing when we square it, it's going to give us 4 meters squared. So the units are going to be different. So we have A, the area equals pi times 4 meters squared. So whenever we have meters squared, or any unit squared, that tells us that we're looking at area. So if we have a punch out a number and it gives us a unit that's squared, that means we're looking at area, so that's good. If we were to do this problem and we tripped up somewhere and we got pi times 4 meters, then that would tell us that we did something wrong because it's not meters squared. We're looking for area when we solve this. So we need to make sure that we put the meters squared there. Yeah, so that just shows that it's two-dimensional. So we're looking at 2 dimensions. If it just gives us, if we just use meters, that's just telling us it's the length. Again, meters squared, that's an area. And if we go meters cubed, that tells us it's a volume. It's 3-dimensional. This is what this number means. It's how many dimensions you're talking about. Okay, let's move on. So circle, triangle, and rectangle. Okay, we got a couple more to do. So if we've done the circle, let's make a new one. Let's try a triangle. So if I have a triangle, it looks like this. Let's say that this is not a right angle triangle. It doesn't really matter if it is or not, but the area of a triangle is the base, so that's a B, base times the height divided by 2. So the base being this side, sure, we can use that. This is the height. So the base times the height divided by 2. Okay. So let's do a practice problem here. Let's say that B, I'll make a new one here. I'll make a new one. Let's make an interesting looking triangle. Why not? Okay. So let's say that the base is 5 centimeters. Let's say the height of this triangle, let's say, is 3 centimeters. Sorry, it's hard to write with a mouse here. So the area equals base, which we're going to use as 5 centimeters, times the height, which is 3 centimeters, divided by 2. So 5 times 3, that'll give us 15. And then the centimeters times centimeters, so we're going to have centimeters squared divided by 2, which equals 7.5 centimeters squared. Again, centimeters squared tells us that it's area, so that's good. That's what we want. So I just want to show you guys where this formula comes from. So the base times height divided by 2. So it's kind of like we can talk about this right now, I suppose. So if I take a rectangle, it is length times width. Length times width. So we'll take, this can be length down here. Doesn't really matter which sides you label as length or width, as long as you keep yourself organized. But the area is length times width, and that'll give us the area for this rectangle, for any rectangle, including squares. Yeah. So I just want to show you guys where this triangle formula comes from. So area equals base times height divided by 2, and that works for any triangle. Because if I were to make, I hope you guys can see this up here. If I were to make a rectangle here, and this is h here, this base times height, that would give me the area of this rectangle, this whole rectangle. Then when I divide it by 2, that gives me the area of a triangle. So if you make a triangle with the same height and base as a rectangle, as the as that corresponding rectangle, it'll just be half. So if I make a triangle in here, how do I erase this? Oh, and anyways, if I make a triangle in here, doesn't matter where the point's going to be, it's always going to be half of this, the area of the rectangle. Yeah, okay, all right, let's move on. Yeah, remembering your units, that's very important when you're doing this. Make sure you have squared units when you're looking at each surface area. So if we look at an example of a combination of simple 2D shapes, so many complex looking shapes can be broken up into simple shapes. I'll just make an example here that we can go through. Let me make a new one. Okay. If I have, pretend that's a straight line. Okay. So if I have a shape here, we'll call this let's say that's 4 meters. We'll say this side is 6 meters. And this is 3 meters. We don't have a formula for this kind of shape, right? We can't just plug something in. There's no length times width divided by 2 or base times height divided by 2 or anything like that we can just plug in for this kind of shape because it's a little more complex. So we need to figure out a way to divide this up into shapes that we know, simple shapes that are usable. So if we look at this, I'm kind of looking, okay, how can I divide this unique shape into 2 shapes that I know? I say, okay, I can kind of see a triangle forming up here. Okay, I can kind of see a triangle up here, and then I can have a rectangle down here. So I know how to find a rectangle, and I know how to find a triangle. So if I add these up, I can find the area of the whole shape. So I'll call this shape number 1 and shape number 2. So if I want to find the area of shape number 1, that is equal to the base times the height divided by 2, right? That's what we just looked at when we talked about triangles. So the base, which is down here, we can say that we know that this is 3 meters. So we'll use that as the base. Base times the height of the triangle, which we know is, this whole side is 6 meters, and this is 4 meters. So if we know that this side is going to be 6 minus 4 meters, so that'll give us 2 meters. So we'll have base times the height, 2 meters, divided by 2. That is our formula for finding the area of this top triangle. So if we punch that in, these 2's will cancel. This is 3 meters times a meter. That'll give us 3 meters squared. That's the area for this top triangle part. And if we want to find the area for the bottom part, for shape number 2 there, it's going to be a rectangle, so we know that we got base times height here, or length times width. So if we go length times width, that's just 3 meters times 4 meters. That'll give us 12 meters squared. We got to make sure we got the right units. I'm all about the units, guys. All right, now to find the total area, we just add the area of this part plus the area of this part. So area 1 plus area 2. That'll give us 3 meters squared plus 12 meters squared. So the area of this slightly complex looking shape, we broke it down into smaller shapes, 15 meters squared. Okay, so there's another portion of this lesson. So finding the surface area for 3-dimensional shapes. So similarly to complex 2D shapes, kind of like the one we just looked at, we can often simplify 3D shapes into easier 2D shapes that we can solve easily. So I posted, or Miss Words posted, an activity for you guys in Desmos to do. It's really short. You can just go through it, and it kind of shows how to find the surface area of a rectangular prism, and you can play around with it. I think it's really cool. So here's your to-do. So there's a short Desmos activity for you guys to complete. I want that done before tomorrow's class. Shouldn't take you more than like 10 minutes. And a few practice questions I'd like you guys to try. Again, there's only a handful of questions. They shouldn't be too bad. If you have problems with them, let me know and I can help you. Yeah, this is just this should be review. If you guys are struggling with it, again, let me know. Send me an email, send Miss Words an email or a message. I'll get back to you right away. I'm always checking my emails. Yeah, so tomorrow, Tuesday the 18th, we're gonna meet synchronously at 1 o'clock. And we're gonna learn some more on surface area and dive deep into some more three-dimensional shapes. Other than that, I hope you guys have an awesome night, have an awesome day, and I'll talk to you later.